Hi guys, and welcome to our last new type of factoring. We're still in the special cases section, which means that for today, it really is just something you're going to have to memorize. There's not like a thought process that you can go through really. It's just like identify it and then boom, answer, which is kind of nice because then we don't have to show too much work. Since we're on our last section, we're going to be all the way down here in our last spot in our factoring book. Today, we are learning, and you can see it on the screen as well, difference of squares. Difference of squares. And a difference of squares is something we're going to use on a binomial, something with two terms. So remember, the number on the side is telling you how big the original problem was. So everything today will be a binomial, only two terms. Go ahead and open up to that last section. Just like with our perfect square trinomials that we were doing yesterday, we're going to do all of our examples on the top, and then we'll have 10 try on your owns on the bottom. So examples on the top, try on your owns on the bottom. And just like yesterday, our first video is going to be about how to identify if something is a difference of squares, and our second video will tell you how to actually find the answer. So let's get started. A difference of squares is it's exactly what it says in the title. So difference in math class means a subtraction problem, and then squares are something that you can take the square root of, perfect squares. And so the generic form that we're going to write for difference of squares is a squared minus b squared. The identifying parts of a difference of squares, first of all, again, it is a binomial. It has to have two terms. It's not three terms. We've been doing a lot of trinomials lately. This is not a trinomial. It's only a binomial. You have to be able to take the square root of both the numbers. Now we're ignoring the symbols. We're just focusing on the numbers. So I have my a squared for my first one and my b squared for my second one. And it must be a subtraction sign in the middle. If it's an addition sign, it's not a difference of squares. Again, the word difference means subtracting. Here's an example with numbers. So 49 minus y squared. This is a difference of squares because I know the square root of 49. It's 7. I know the square root of y squared. It's y. And it's being subtracted. So we're good. Before we go into our try and our owns, I want you to write down the perfect squares that you should have memorized. Now, you probably already have these memorized. There's something you've probably known for several years, but it's helpful to write them in our book. We don't have very many examples today, so you can use all of this space up here to write down these perfect squares. And the perfect squares will also help you with yesterday's section, the perfect square trinomial section. Okay, so you're looking for, when you're trying to find a difference of squares, you're seeing, the number that's underneath the radical. So we're hoping that the problem has a 1 or a 4 or a 9 or a 16 or a 25 or a 36, right? So we're hoping it has one of those numbers. And then the number after the equal sign is what you get after you square root it. And we will need to square root it as we're solving. I also included in here how to take the square root of a variable. So to take the square root of a variable, it has to have an even exponent. So you'll notice that all of my exponents are even numbers, 2, 4, 6, 8. Right? Didn't include 3, didn't include 9. To take the square root of an exponent, technically what we're doing is we're dividing it by 2. Now, I feel like you've probably done the square root of x squared before, and you're like, oh yeah, they're opposites. They just cancel, and it turns into an x. But technically what we're doing is we're doing the 2 from the exponent divided by the 2 from the square root, and 2 divided by 2 is 1. So for this one, x to the 4th, 4 divided by 2 is 2, 6 divided by 2 is 3, 8 divided by 2 is 4, and so on. So if you have an even exponent on your variable, then you can take the square root and you just divide by 2. Once you're done writing these down in your book, now we're going to move on to the bottom section. So you wrote these up top because you have a lot of space up top. We're going to do our 10 try on our owns. Just like yesterday, you can do 5 over here and 5 over here. And just like yesterday in our first video, we're focusing on, is it a difference of squares? So we are not factoring these right now. Right now, we're just writing, yes, it is, or no, it's not. So go ahead and pause the video and write down the problem and then follow it with the word yes or no. Let's see how you did. So that first one is a yes. I know the square root of x squared. I know the square root of 4, and it's being subtracted. So perfect. The second one is also a yes. For the second one, you do have to be able to take the square root of the 9 and the x squared, but 9 is a perfect square, so that's fine. And 1 is a perfect square, so I always get a lot of students who forget that you can square root the number 1. It is 1, and it's on that list that you wrote earlier. Number 3 almost looks like a difference of squares. I know the square root of 4. I know the square root of x squared. That 2, though, in front of the x squared is kind of screwing me up a little bit. You can factor out the 2. It is a GCF. But after you factor out the 2, it's still not going to work because then we're going to change that 4 at the end into a 2. And I still don't know the square root of 2. So if you want to see what that looks like after you factor it out, it would become 2 and then x squared minus 2. So remember, today we're just identifying, is it a difference of squares? We're not identifying, can I factor this? Number 3 is factorable. I can take out a GCF. But since I'm trying to figure out if it's a difference of squares, I'm going to say, no, it's not a difference of squares. All right, number 4 looks like it has the same issue as number 3 had, right? I don't know the square root of 2. I also don't know the square root of 8. But when I factor out that GCF of 2, x squared minus 4, it turns into a difference of squares. So I'm going to go ahead and say yes for this one. Once I factor out my GCF, I now do have a difference of squares, and then I can factor that. All right, number 5 is a little bit tricky. I do know the square root of x squared. I do know the square root of y squared, but it's not a difference. It's an adding problem. It's a sum. So number 5 is not a difference of squares. And number 5 actually is prime. We could not factor that one at all. Okay, number 6. Number 6 looks pretty good. I've got the square root of 25. I've got a subtraction sign, but my exponent is an odd number. Since my exponent is an odd number, this is not a difference of squares. Remember, your exponent has to be even. Okay, number 7. Number 7, my 9's good, my y square is good, my minus sign's good. This x and this y right here, not so good though. So not a difference of squares. This one is factorable. I can factor out a GCF of y, but it's not what we're looking for today. All right, number 8 looks a little tricky. I know the square root of 16. I know the square root of x squared, but it looks like an adding problem. However, I've got a negative sign in front of the 16. So if I just flip-flop the order, then it is a difference of squares. So if I move the positive x squared first and the negative 16 last, now I can say, yes, this is a difference of squares, and I can factor this. Now on number 9, we cannot do that because both numbers are negative. So in a difference of squares, we do want one of the numbers, our first number, to be positive, and we want our second number to be negative. So if they are both negative, then it's not a difference of squares. It is factorable. I can factor out a GCF of negative 4, but it's not what we're looking for today. All right, last one, number 10, is a difference of squares. We said on the previous slide that as long as your exponent is an even number, you can square root it. And I do know the square root of 81, and it is subtracting. This concludes our first video identifying if it is a difference of squares. In our second video, we will learn how to factor and write our final answer.